Make yourself comfortable because we're about to find out some of the very high-tech engineering behind agriculture.
I speak to a lot of farmers, and in engaging with farmers as well, a lot of farmers are probably the most innovative people I know. They have a tight budget, they have to be realistic in what they can do with it, and they use the resources available to them. So I would say, farmers are some of the most innovative people that I know.
Hello there, my name is Dusty Rhodes and welcome to Amplified, the Engineers Journal podcast. Today we're diving into the agricultural sector and discovering the differences and commonalities with engineering in general. We'll also hear how it's being impacted by sustainability and where AI is playing a part in its future. Joining us are three engineers who are passionate about creating a better future for the sector through innovation and sustainability measures. They are Associate Professor and Vice Principal for Internationalisation in UCD College of Engineering and Architecture, Tom Curran. Tom, thank you for joining us today.
Good to be here, thanks.
Mechanical Engineer with Agrigear, Neil Pigott. How are you?
I'm very well, thank you very much for having me.
And Agricultural Inspector with the Department of Agriculture, Food and the Marine, Robert Leonard. Thanks for giving us your time today.
Good to be here.
Robert, can I start off with yourself? Because the Department of Agriculture has got a terrific overview. How does the department view engineering specifically within the sector of agriculture?
Within the sector, I suppose, we're a small team in the Department of Engineering from an engineering point of view. But I suppose it is very important to ensure, quality buildings is coming from the grant side and to ensure that the department grant aids of farm buildings, farm structures, is to ensure that what we're grant aiding provides a good quality structures for farmers, that they will have a right longevity but balancing cost and also protecting the environment. So it's important to look after the environment. We're working with the latest technologies, having that input to the engineering input to ensure, look at correct grades of concrete, correct steel sizes for buildings, but then machinery and equipment is suitable for the proposed projects and the works that needs to be undertaken in the agricultural sector. So it's a very broad-ranging area in some ways. While we're focusing on the grants, it does feed out and is also used for a structural point of view for the storage of all slurries, whether they're getting grant aid or not. Farmers have to follow the department's specifications and requirements.
Do you find it hard to push the engineering angle within the department, or is there an openness to it?
There's an openness to it to ensure that it's pushing the quality and the needs and the balance of what's been going on. People ask, why do we need so much steel in buildings? It's there to ensure that the building will be structurally sound, it will last. Improve animal welfare, make sure the animal welfare is right from ventilation and make sure the air quality is right. So the department does see the need for all of this to make sure it is all correct because it has an impact on the animal welfare, and to make sure structures are correctly built to ensure that it protects the environment, protects water quality. They're very important aspects, and the department sees the need to follow those and make sure they're right. There's a lot of legislation around that as well.
Can you give me any kind of example or a particular project that demonstrates that?
I suppose it's a few years ago, but we continually develop our concrete specifications. We brought in the use of what they call GGBS cement. So it's the granulated bathrock slags to reduce the carbon emissions from concrete. So that has been brought in and is fully allowed within the department concrete specifications. With the concrete, we need to ensure the correct durability, and the use of novel additives actually helps to improve that. So it ensures we have good quality concrete that's going to last well on an ongoing basis.
Neil, can I come across to you and ask you about engineering and how you see it differing in the agriculture sector?
Specifically in the machinery section, which is my forte, if you like, we deal in Agrigear with a lot of the agricultural engineering manufacturing companies in terms of the likes of McHale over in Mayo, Abbey Machinery down in Tipperary. We manufacture wheels for a whole variety of customers, and we develop solutions for people to enable them to meet and contend with the challenge of the differing climate that is going to be hosted upon it. The issue of, for example, slurry spreading, which has become very almost politically motivated in terms of the influence of the likes of Dutch practices, which are very restrictive in terms of the timelines and the quantities of effluent that can be spread throughout the spreading season. The application of engineering to promote and safely handle the likes of that manure going out in terms of it's making the nutrients available to the growing plants. The ongoing engineering input into that is determining and helping farmers and contractors deal with the application in terms of getting more manure out at the right time, but also conserving the soil so that you're not compacting the soil as previous generations would have done in terms of heavier machinery is now being used, so larger tires, larger wheels to enable more application to go out, but conserving the soil. And it's an ongoing issue in terms of labour requirement as well, because the farmers and contractors are getting such a big problem now with labour. People want to sit at a computer all day, every day, rather than sit on a machine all day, every day. So in terms of the engineering input, certainly from an Agrigear perspective, we're seeing a lot more larger equipment requirements, not just in Ireland, but Europe-wide. And also, we also supply customers to Costa Rica, New Zealand, Australia, Canada. So the engineering input to what farmers and contractors are doing at the moment is the machinery's getting bigger, but you have to be able to cope soil-wise with the conservation of your productive land at the end of the day, because the soil is the key. You have to preserve it, conserve it, and make sure it is fit for purpose, else nothing will grow.
These are engineering problems that we don't hear of often on the podcast. And I mean, it really is eye-opening to hear how you have to think about that, about the machinery and the land and the quality of the soil and everything. Tom, can I swing over to you? Because you're with UCD and you're kind of more looking at the research side of things. What kind of research is going into agricultural engineering today?
Dusty, I think going back to what Robert and Neil were saying there, very much the research touches on the issues that they've raised there in terms of the environmental impact, sustainability of the whole agri-food sector. And it's not just at the farm level, buildings that Robert was referring to, and ventilation, gaseous emissions, the soil that Neil was referring to, nutrient management, all of those issues are covered in terms of research. And I would say it's across the whole chain, from the farm to the fork, from getting the harvest out of the fields or farm buildings, right through to processing of the food so that it's ready for consumers to eat in a safe manner, but also in the most sustainable way as well.
You led the Horizon Europe project, BO, is that it?
It's a tough one. Well, let's say the Irish partners call it BIO. Bio is referring to the bioeconomy, and bio being the Irish word for live or alive. So that's really all about, it's a European project. I'm the coordinator of it. And again, it's a European project with 15 partners across 10 European countries. And we're developing education lesson plans in primary and secondary schools. And it's all about the bioeconomy, the living economy around us, which includes farming, food production, forestry and the marine. So we're trying to get the message out to younger people and to highlight opportunities for in their later career as well, that they go into engineering and science careers.
I would like to add to the previous comments in terms of the application of robotics and the horizon scanning that is going on, in particular to crop production and crop protection. With the application of robotics in agricultural engineering, this is an industry now that is coming really strongly on. There's a lot of research going on, particularly in the UK, where I hate to refer to it with the Brexit word, because they have had great issues sourcing seasonal labour that previously would have gone across from the likes of Eastern Europe to harvest fruit crops, for example. So now the UK is putting a lot of work into the likes of robotic harvesting to solve or potentially solve a lot of their labour issues. But the applications of robotics and its application within agricultural engineering is really in its genesis mode. The application of this sort of engineering will blossom, I think, in the very near future to cover a whole host of more applications, because this technology will not take away people's jobs, but it will actually enhance people's jobs. So you'll have robotic manufacturers, you will have robotic programmers, and then you'll have people who will actually maintain the robots in the field. People are scared of technology when they hear of robots. For example, the likes of robots manufacturing cars. But out in the field, it's a different thing because you have to make them weatherproof, waterproof. They can work 24/7. They don't need tea breaks. They don't need cigarette breaks. They can work unsupervised to get the job done. So from certainly my background reading in the journals, the scientific journals, and also in the general press and farming media, this is an area that will grow.
Robert, I see you nodding your head there. Is the department kind of looking at automation and even advanced to robotics?
We're seeing a lot of it already coming through. I suppose one of the older technologies now, if you call it that, is actually robotic milking of cows. So that's becoming quite commonplace now. You have mundane tasks being taken over as scraping of animal housing by robots. We're also seeing then in the horticultural sector, it's coming in is automatic weeding, planting, fully robotically controlled systems. So to reduce pesticide usage, reducing fertilizer usage, so you're placing fertilizer just where it's required. These are technologies that are actually in the field already as it is. And there's a lot of technology coming on from the pesticide application side, looking at identifying weeds, diseases, and applying pesticide just to the points where it's needed. So using vision control to actually decide whether or not to actually apply the pesticide to a particular plant. And it is developing also then going on into full control of machinery in the field, steering control of machinery. These are things that are actually there now being used by farmers to assist them to maximize their output, minimize inputs, really to get that high return. All that information can be feeding into a higher level of AI to actually to understand what way to apply crops and to get the best return while having the least inputs.
Tom, from your research abroad and here at home, how are you seeing automation and robotics affecting engineering and agriculture?
Well, it's definitely a growing area, as Robert and Neil gave examples there. There are pieces of equipment already like robotic milking, sensors right through the agri-food chain. And I think you will see a lot more of the use of sensors and real-time information coming back to the users. It may well be a case of in the future that there will be sensors used for compliance issues. So, for example, as we know, climate change and the biodiversity crisis is upon us, and I could see that sensors could be used to show that the farmers are actually doing a good job in reducing their impact on the environment, improving water quality, reducing emissions of gases as well, going right into the food industry as well. There's a huge potential there for the use of inline sensors in the processing factories, let's say in dairy milk processing, making systems a lot more efficient, reducing their energy and impact on the environment as well.
So we've mentioned automation, we've mentioned robotics, you've brought in sensors, Tom. Can you tell me a little bit about it? And you've given great examples of what we could do with the data. But from an engineering point of view, who analyzes the data and how?
Well, I suppose it depends on the application. There's a lot of research going on in terms of how the data could be used in the most efficient way possible. And because you're getting so much data, let's say harvesting, if you like, you could be generating like thousands, millions of data points but it's actually no good to you unless you analyze it properly. And that's where we get on to machine learning, like artificial intelligence. How can we actually use that data and a user-friendly manner so that they can actually take actions or decisions, make decisions on that basis? Now, some of those decisions could be made automatically by, let's say, as was mentioned earlier by Robert in terms of weeding, but it also could be sending a message to a farmer, let's say on a dairy farm, to say this cow has a lameness problem, you need to check this cow, as the case may be.
Moving away from artificial intelligence just a little bit, Neil, have you kind of seen the introduction of smart farming? I mean, I'm thinking of like drones and sensors and the Internet of Things. Is that becoming part of your world?
Certainly, for example, the likes of the harvesting equipment that's out there now. I'm thinking of a combine harvester that's used for harvesting cereals, wheat, grains, barley, oats, etc. So the technology that is available to harvest and monitor on the move, and also to direct a machine that doesn't need an input for steering, for example, down a field to tell it where to go. It's satellite driven. The material that the machine is harvesting is being continuously monitored in terms of, for example, moisture content. So the farm manager, he can then tell his grain drying operation back at base, does the grain need to be dried to a specific moisture content and how much grain is coming through from the machine. So it's the entire process of the field produce going into post-harvesting technology. The stream of information being generated is of immense value to the farmer and the farm manager in terms of what they need to do with that product to get it fit for purpose to the fork.
Can I ask, certainly for Neil and also to Tom and to Robert, farming is a very traditional industry. Do you find that farmers are resistant to these new changes?
I think the farming community in general is quite adaptive, and I think they have to be. For example, milking robots. I know of several people around County Meath, where I am, that have installed robots over the years. Now, it takes the drudgery out of milking cows, and they have seen benefits in terms of throughput. The yield does increase because the cow can choose when to get milked, but it doesn't replace the good herdsmanship or herdwomanship in the farming business. Because, for example, the robot won't tell you when a cow is lame. It'll tell you the fat content and the protein content, for example, of the milk, but it won't tell you when the animal has an issue with a sore foot. So you still need the input of a good farmer, a good contractor, a good operator to make the most of the technology that they are embracing.
Robert, there's a huge amount of technology that we're talking about and very technical. And when it comes to the future of the industry, what kind of obstacles do you think the industry is facing?
I suppose from a farming point of view, it's a certain amount is the scale of some of the smaller farmers to get them to take up this technology that is there. You have a lot of the larger dairy or tillage farmers who have the funds or have the knowledge. They're rapidly taking it up, but I suppose it's a fragmented industry in a lot of ways as well, and that can take time to develop through. I suppose it's bringing through younger generations who understand computerization as well. The future, there's going to be a lot more monitoring, I'd say a lot more robotic controls, but you need to be monitoring what's going on. It's not a case of just watching and sort of letting the robots take over. The farmer needs to understand the information they're getting and actually apply that information. It's down to us from an engineering point of view to be able to translate all this data and say, look, this is what this means. You need to be able to combine which pieces of information you need to bring together to combine and to be able to highlight those bits for the farming community.
Tom, you want to jump in?
Yeah, just on the point of your question about is there a resistance to change from farmers, but farming, I suppose, is such a a long-standing industry. We all need farmers to produce our food. Yeah, I would say it's like everything else. Some people are resistant to change naturally, but I think I would also say, on the other hand, like I grew up on a farm and I'm currently a part-time farmer as well, but I speak to a lot of farmers, and in engaging with farmers as well, a lot of farmers are probably the most innovative people I know. For example, I've been running a module in UCD, a biosystems engineering design challenge, applying engineering to the agri-food sector effectively. I've been running this module for 20 years now, and it's open to any student in UCD to take it. But I find the students who are the most inventive are the students who have grown up on a farm. They just have this innate ability that they look at what the resources they have available to them and make something of it. And I think there's that natural innovation spark in a lot of farmers. They have a tight budget, they have to be realistic in what they can do with it, and they use the resources available to them. So I would say, farmers are some of the most innovative people that I know. So there is a willingness with a lot of farmers to adopt new things. And I would say, going back to Robert's Department of Agriculture as well, there's a new scheme now in operation called Acres, and I think that will really drive further innovation in terms of climate change, also helping with the biodiversity as well. I hear now farmers discussing their biodiversity scores. They're comparing each other's performance and seeing what will I do for next year to improve those scores, and which will be financially rewarded as well by the department scheme.
You're saying there about, farmers are comparing scores and they're having chats and stuff like that. Can I ask you about kind of engineers who are working in the farming sector? Are events like, the Ploughing Championships, which we have every year, is that important for engineers to get together and share ideas and inspire each other?
I would say yes. Going around kicking tires, it's always an interesting exercise to see what the fella next door has come up with in the last 12 months. And there's always, he's done it that way. That's interesting. Yeah, absolutely. It's your shop window, the Ploughing Championships, and we always look forward to it at Agrigear. We'll have an enormous display with an enormous amount of wheels and tires on it. It doesn't stop you going around looking at what other people are doing. Everybody's trying to improve, and every engineering industry is of a continuous improvement nature. You have to be involved in sustainability, number one, but competitiveness, number two, as well. The Ploughing Show, it's the main show for agricultural engineering on the island of Ireland. So it's a huge shop window, and it's an opportunity to demonstrate, broadcast what you're doing and how you're doing it.
Let me just get into one or two final questions with y'all, because I want to ask about sustainability, and we've mentioned climate change. I mean, it's such a huge thing at the moment. What challenges, from your point of view, is the agriculture sector facing due to climate change that engineers need to work on?
There's a huge range of areas to focus on. There's the changing climate, changing weather patterns. So you're looking at changing harvest, planting seasons, machinery needing to change, how to look after livestock in a changing climate, weather patterns for more extreme weather events. It's protecting farmyards, but also, I suppose, ensuring land is correctly drained. The drains are going, it's the correct level of drainage, but also then putting in areas, wetlands to actually slow down water movement. So it's not just a case, if you move all the water off land too quickly, you're going to cause problems further downstream. So there's a tricky balancing act to be put together in terms of how water is managed, how biodiversity is managed, the application of pesticides, fertilizers. It's how to do it without them being washed away, and where the crops are actually getting the correct return, you're getting what they need. And then I suppose look at how to harvest crops in potentially wet weather or additional drying or maybe irrigation, which we haven't had to use before to a great extent.
Tom, can I ask you kind of about climate change and sustainability, because it is happening all over the world. What innovations are you seeing through research and abroad and here in Ireland that are being explored by engineers to address those challenges?
Well, I would think part of the reason of bigger machines with more, we'll say, sensors on it as well, would be that you have probably a shorter time window to do certain jobs throughout the year, like planting or harvesting. It's very much tied into the climate and weather patterns as well. And going back also to the point about smart farming, is there such a thing as smart farming? Well, it's well established now because everybody has a smartphone in their pocket. They're looking at their weather apps to see, and they're making decisions on their farm based on the weather forecast. And I think that will develop further into the future, that there'll be more automated messages coming back from maybe service providers in the agriculture sphere, that now is a good time to do ABC, whatever the job is. It'll be more tailored messages. And I think there's a lot of work being done as well in terms of life cycle assessment, looking at the actual carbon footprint of various actions throughout the farm, both in terms of nutrient management, how crops are harvested, how animals are managed, how buildings are managed, conserving energy and nutrients throughout the whole agri-food chain. And I think everything is interlinked, and we see this. This is a message that we are promoting through our European project on BioBio in connecting with students in primary and secondary schools as well. We have teams such as Food Loop, Life Below Water, Forestry, Outdoor Learning, and Interconnectionists. So it shows if we do a certain action, we have to take into account so many different factors: climate, nature, water, air, etc. And this is a message I think that we need to communicate to the general public as well, how engineers and scientists are working to be more environmentally sustainable, but also to take into account changing weather patterns for the future as well.
Can I throw a question out to all of you? Have any of you seen any particularly good innovations or examples of how other people are addressing these issues of sustainability and climate change?
I suppose one of the areas I've seen, is in the slurry spreading technology. A couple of companies, they're putting together sensors to actually evaluate slurry as it's being spread in terms of its nutrient content. So actually adjusting the spreading of slurry to maximize the output. So as it goes around the field, the actual tanker is actually adjusting the application rate. So you're getting a known level of nutrients applied per hectare, so reducing the amount of artificial fertilizer that would be actually used. So you're really getting a very accurate reading of what's being applied where. So you get that good control in terms of protecting the environment, and then actually really benefiting from the nutrients that are in the slurry as well.
Yeah, I just to highlight another project I'm involved in. It's been funded by Enterprise Ireland and some of the dairy companies as well. It's the Dairy Processing Technology Centre, combining the research of a number of third-level institutes and Teagasc, etc., and the dairy industry are involved in as well. So it's looking at the whole chain of milk production coming through the factory gate and how that's managed in an environmentally friendly way. And it's looking at things like the milk characteristics coming in from different farms and how that will impact on the process itself inside in terms of the producing different products and trying to do that in the most energy efficient way and reducing carbon footprint, water use, etc. in washdown. Also looking at the wastewater coming out of that process and what can be done with that, because at the moment that's a cost to the companies, but potentially in the future that wastewater could be converted into a fertilizer product, a biofertilizer, which then could be marketed in terms of organic farming. And I see that not just in the dairy industry, but other sectors as well. And that's an opportunity, I think, for the farming community and the food industry as well to produce these biofertilizers. And it would tie in with some of the things that Neil and Robert have been saying as well about nutrient management on farms, how manure can be spread on these bioproducts. These biofertilizers will be part of that picture to make farming more sustainable in the future as well.
Well, guys, I have to say, I'm not from a farming background myself, so I didn't know what to expect on our podcast today, but I can tell you've definitely given me a whole ton of food for thought. Tom Curran from UCD, Neil Pigott from Agrigear, and Robert Leonard from the Department of Agriculture. Thank you so much for your insight and for sharing with us today.
I do.
You're welcome.
Thank you.
If you'd like to find out more about Tom, Robert or Neil and some of the topics that we spoke about today, you'll find notes and link details in the show notes area on your podcast player right now. And of course, you'll find more information and exclusive advanced episodes of our Engineers Ireland Amplified podcast online at engineersireland.ie. Our podcast was produced by dustpod.io for Engineers Ireland. If you'd like more episodes, just click the follow button on your podcast player to get access to past and future shows automatically. Until next time, from myself, Dusty Rhodes, thanks for listening.